Previously, we deal with the remainder theorem, but for this lesson, we will be dealing with the factor theorem. The factor theorem states that the polynomial p of x has x minus r as a factor if and only if p of r is equal to 0. There are two parts of the proof of the factor theorem. Given a polynomial p of x, the first one is, if x minus r is a factor of p of x, then p of r is equal to 0. And the second one is, if p of r is equal to 0, then x minus r is a factor of p of x. Let us prove the factor theorem. The factor theorem is the consequence of the remainder theorem. X minus r is a factor of p of x if and only if the remainder of p of x divided by x minus r is 0. By the remainder theorem, r equals 0 if and only if p of r is equal to 0. Thus, x minus r is a factor of p of x if and only if p of r is equal to 0. Let us see how the factor theorem is used with the following examples. For example number 1, determine whether x minus 3 is a factor of the polynomial, letter A, p of x equals 2x cubed minus 5x squared minus x minus 6, and letter B, p of x is equal to 3x cubed plus x squared minus 2x minus 15. Let's work on for the solution of letter A. So for letter A, we will be solving p of x equals 2x cubed minus 5x squared minus x minus 6. So on this case, we will be solving or calculating for the value of p of 3, since our divisor is x minus 3. And then we will substitute the value of 3 to each values of x here. So we have 2 times 3 cubed minus 5 times 3 squared minus 3 minus 6. And then we simplify the exponents. So we have 2 times 27 minus 5 times 9 minus 3 minus 6. Then we simplify. 2 times 27 is 54 minus 5 times 9, which is 45 minus 3 minus 6. So I'll be combining the positive ones. So this is the positive 54. And then later, I will combine all the negative. Negative 45 plus negative 3 plus negative 6 is equal to negative 54. 54 minus 54 is 0. So therefore, p of 3 is equal to 0. Since p of 3 is equal to 0, therefore I can say that x minus 3 is a factor of the polynomial 2x cubed minus 5x squared minus x minus 6. Let us proceed in solving letter B. So for letter B, we will be again substituting all the values of x into positive 3. So we have 3 times 3 cubed plus 3 squared minus 2 times 3 minus 15. Simplifying all the exponents, we have 3 times 27 plus 3 squared is 9. 2 times 3 is 6 minus 15. And then we multiply. 3 times 27 is, we have 81 plus 9 minus 6 minus 15. I'll be combining the positive first, 81 and 9. So I have here 90 minus
Negative 6 and negative 15 is negative 21. And then subtract, which is 69. So therefore, the value of P of 3 in this polynomial equation is 69. Since we have a remainder, which is 69, therefore, we can say that x minus 3 is not a factor of the polynomial 3x cubed plus x squared minus 2x minus 15. Let us see how the factor theorem works with this example. So we need to find the value of k so that x plus 3 is a factor of 4x cubed plus kx squared minus 6x plus 9. So to show that x plus 3 is a factor of the given polynomial, we must prove that p of negative 3 must be equal to 0. Or, while we substitute negative 3 into this equation, we must obtain a value which is 0. So, how do we do that? So, by using the factor theorem, we have 4 times negative 3 cubed plus k times negative 3 squared minus 6 minus 3 plus 9 equals 0. So we just substitute the values of x into negative 3 and equate the equation into 0. And then, we simplify them. So we have 4 times negative 27 plus negative 3 squared is 9k. Negative 6 times negative 3 is positive 18 plus 9 equals 0. Then we simplify. 4 times negative 27 is negative 108 plus 9k plus 18 plus 9 equals 0. So we are here to solve for the value of k. We want our k to be alone on the left side of the equation. So, what we have here is 9k, negative 108 plus 18 plus 9 is equal to negative 81 equals 0. And then, we transfer the negative 81 to the right side of the equation. That's why we have 9k equals 81. And then, we divide both sides by 9. And then we cancel. So, the value of k is equal to 9. So, the value of k, so that x plus 3 will be a factor of 4x cubed plus kx squared minus 6x plus 9. It should be equal to positive 9. Now, to complete the polynomial equation, we now have 4x cubed plus 9x squared minus 6x plus 9. So, this is now our p of x. So, there's a way for us to be able to check whether the real value of k is really 9. So, we will be using here synthetic division to divide this polynomial by x plus 3. So, we will be using synthetic division. So, let us get the coefficient of this polynomial. We have 4, 9, negative 6, 9. And then, we're going to place the r here. So, positive 3, this will become now negative 3. Then, we bring down. We have 4. 4 times negative 3, which is negative 12. 9 minus 12 is negative 3. Negative 3 times negative 3 is positive 9. Negative 6 plus 9 is positive 3. 3 times negative 3 is negative 9. 9 minus 9 is 0. So, the remainder here is 0. So this one really proves that x plus 3 is a factor of the polynomial 4x cubed plus 9x squared minus 6x plus 9. So it means that the real value of k is really 9. So that's it. So let's have this example. What is the value of k so that x minus 1 is a factor of 5x cubed plus kx squared minus 6? So if x minus 1 is a factor of the polynomial 5x cubed plus kx squared minus 6, we know that from the factor theorem that p of 1 is equal to 0. So how do we do that? We then substitute the value of x by positive 1 in this equation. So we have 5 times 1 cubed plus k times 1 squared minus 6 equals 0. Then we simplify the exponents. We have 1, 5 times 1, plus 1 squared is 1 times k is k, minus 6 equals 0. Then we simplify this. We have 5 plus k minus 6 equals 0. So we bring down k. 5 plus negative 6 is negative 1 equals 0. And then we transfer the value of negative 1 into the right side of the equation. So the value of k is positive 1. So to complete this polynomial, it should be 5x cubed. The value of k must be equal to 1. So that's why we have plus x squared minus 6. Now let us check. Now to check whether our answer is correct or not, we will be using synthetic division to divide 5x cubed plus x squared minus 6 by x minus 1. So how do we do that? First, we need to complete the coefficients. Here we have 5, 1. Since we don't have linear term, we have 0 for the linear term, minus 6 or negative 6. And then we're going to place positive 1 on the upper left here. So we bring down 5. 5 times 1 is 5. And then we add 1 plus 5 is 6. 6 times 1 is 6. 0 plus 6 is 6. 6 times 1 is positive 6. Negative 6 plus 6 is 0. So, since the remainder is 0, it proves that x minus 1 is a factor of 5x cubed plus x squared minus 6. So, the value of k, which is 1, is correct.